Greetings, my name is Steve Johnson, and welcome to my session, Real Classroom Examples of Engineering in K-12 Classrooms. We're going to be walking through some great examples across Moore County schools of things that are happening in our classrooms just to kind of get your wheels turning and see if there's anything that you can apply back in your buildings. So without further ado, let's get started. So let's get started. First of all, I just want to give you a little bit of information on who I am. Again, my name is Steve Johnson. These are my girls. I've got a 9th grader, 7th grader, and a 3rd grader, Emily, Kenna, and Hannah. I am the Assistant Director of Technology here in Moore County Schools. I work with a great team of digital learning and STEM folks and facilitators here in Moore County. I did used to be a teacher. I'm a former kindergarten and 2nd grade teacher, and taught for 6 years and then moved into tech facilitator position for K-12. So I did that for about 9 or 10 years before moving to this current position. And like I said before, I really work with a great team of facilitators and teachers here in Moore County Schools. I work a lot around digital learning, STEM. We are a ton into robotics and also engineering. So today in this session, we are going to walk through just a few things before we get to our examples. First, we're going to talk a little brief context of Moore County Schools and kind of where we are and how we got to this point where we have so many examples that we can share. Walk you through the engineering design process and what it looks like in Moore County, along with some common elements to look for whenever you start implementing that process in your own classrooms or schools. Then, of course, we'll get right to it. The bulk of this presentation is going to be just a bunch of examples that we've got going on across the grade levels, K through 12. And we'll wrap up with a way to find out more, to go more in depth with more lessons and the structure and how you can find them. All right, so this slide's a little bit busy, but I'm going to break it down a little bit. This is just a brief context of where we are in Moore County Schools and how we got to where we are as far as engineering in our classrooms. Really all start off with robotics. So 6 years ago in 2014, we had some robotics kits that were just laying around and gathering dust, and so we decided to kind of invigorate that and pull them out of the closets, dust them off, and we started robotics clubs in all of our schools. And they were after-school clubs. And so any of you that have done robotics before, you probably can understand that that was an instant hit. These were old EV3 kits, Lego EV3 kits. And so our robotics clubs grew exponentially, and we saw huge student demand for robotics in our after-school clubs. We spread those robotics clubs to all schools, and what you're seeing here on the timeline is you're seeing our a movement from robotics in Moore County, starting from 17 teams and all the way up over to 100 teams now. So what happened was, as we saw this interest, we saw that kids were really good at design and engineering. They were really retooling their robots. They were retooling their programming. They were extremely persistent. They never wanted to fail. They failed often, and they overcame those failures to really succeed. And we saw tremendous growth mindset in our kids. So we kind of followed the students' interest. So as we saw that, we thought, okay, how can we get this interest into our classrooms? And so that's really where engineering and design started taking hold in Moore County Schools. That happened about 4 years ago. We got together and designed some engineering projects for grades K through 5. And we designed a robotics project and a non-robotics with traditional materials like duct tape, cellophane, tape. And we implemented those in our K-5 classrooms. They were tied to standards, and immediately our teachers really loved those projects. And they saw that our students were really doing great work and collaborating and overcoming challenges and failure in our classrooms. So since then, it's really snowballed, and so K-5 is where we started. And as kids went up to middle school and high school, we started thinking, well, how are we going to change our classrooms to meet that demand? And so with the help of our North Carolina Digital Teaching and Learning Grants, of which this conference is a part, we were able to kind of pour fuel onto that fire and really move into 612 and design a lot of great engineering design projects in those 612 classrooms, which we've been implementing in the last 2 years. So that's just a brief history. Like I say, that might help inform you in your school about how you can get started. You really want to get started generating interest, generating a buzz. because once students start doing these projects in classrooms, it's a very palpable feeling. And just build off that and follow that buzz to really make changes inside your classroom instruction. So, this is the engineering and design process that we use in Moore County Schools. We use this all the way down to kindergarten, all the way through 12th grade. We found it to be really helpful to have a standard process that we can all kind of have the same language that we're speaking. And if you Google engineering design process, you'll find a ton of different examples. This is just the one that we've chosen and kind of modified for our own purpose. So I'm just going to walk through it quickly in case you've never seen one before. In our case, we start off with asking the question. We set a task. And so once we introduce the task to students, we don't answer a lot of questions right off the bat. The students are the ones to answer those questions and to ask those questions and to figure out what questions to ask. And so we set the task and we don't give much more information on that, and then we start generating questions. Students in this process, it's important to note that they are working in pairs or small groups. This is not individual work. All the way down to kindergarten, we pair them up so they can work on that process of communication and brainstorming as a team. So after they ask those questions, then they start imagining. They start brainstorming ideas. And so that's when the group starts bouncing off ideas. How do we solve this task? How do you think we should do it? How do you think we should do it? And then what they have to do is they have to come together and choose the best plan. Choose the best idea. And it doesn't have to be the one that's going to work. It's very often the one that will fail. But they have to come in together and collaborate to create and choose a best idea. A first idea, I should say. From that idea, they develop their plan. And this is a really integral part of our process. They have to plan. They have to make a plan before they start getting materials. So they draw a diagram, they think about the materials they need, they think about their budget if there's a budget involved, and they go ahead and work through that plan together as a group. Once they have a plan together and they've proven that they've worked together to create it, then they move to the creation phase. So that's where they follow their first step at the plan and they try to create whatever they need to design to accomplish the task. Now here is where you get a lot of failure, and that's going to be something we talk about, is we really try to bake a lot of failure in, because once students fail, they start to learn how to improve and kind of recreate. And so that's where you get this kind of what we call rapid prototyping, where they create something, they try it out, they observe it really good to see how does it work, and when it fails, they go back and they retool and they fix. Try again, retool, try again, retool. So that's the process that we use, and we try to overlay that over all of our projects and lessons that we use in Moore County Schools. So, common elements to look for. So as you look at the examples today, these are some of the common elements that you'll see. First, I mentioned it is collaboration. They're going to be working through the design process in partners or small groups. That is very important. And it forces them to communicate and talk about the task at hand. The other thing that you're going to look for is constant improvement. So the more that you do these lessons and mini projects that are engineering and design, the more you build that growth mindset into your students. The work is never done. It can always get better. And so that's a mindset that really sets in with your kids. One thing you'll notice is failure is baked right in, and that's on purpose. So whenever you start looking at these examples today, and you start thinking of your own classrooms, you want to think about not making the prospects too easy for your students. If it's too easy and all the kids are successful, you need to go back to the drawing board and figure out a way to build some failure in. Because that's really the key part of this process, is the failing and the persisting. And so as we look at these projects, I might be mentioning some ways of how we've baked failure right in on purpose. One thing that you can look for in your classrooms that we see a lot in our classrooms that we love as an outcome is that a lot of our traditionally marginalized students or labeled students really become leaders in this process. So the traditional kind of method of schooling that we've been kind of dealing with for the last 10-15 years of standardized tests and students getting the right answers, a heavy focus on math and ELA skills, those skills don't necessarily translate to engineering and design and building. And so what you see is when you start doing these projects, you're going to see students that traditionally might be labeled as not successful in school because of their math or ELA skills, being extremely successful with this prospect and with this process. So they become leaders. They become the kids that have traditionally been successful look to these students to lead the way, and that is very profound to watch happen in a classroom. And last but not least, I just want to mention that most of these projects that you're going to see in these examples are based around content standards. It's not fluff. And so we're teaching a concept, we're teaching a content standard, and oftentimes we'll look for the standards or the content that's the most difficult for students to grasp, the one that we've had the most trouble with. And so that's a lot of times where we start, especially in 612. We'll look at our data and say, what are the concepts our kids are having the most difficulty with? And that's where we usually put these projects and mini lessons in. Because you're going to get much more engagement, you're going to get much more deep knowledge of a subject through these type of projects. Although I do want to mention, there is a time for fluff. So, just teaching the process itself, even that might not be connected directly to standards, a lot of times we'll do introductory lessons where students walk through the process, but the more you work through that process, the better they'll get at it. All right, so we're going to get started with some classroom examples. These examples are going to be quick examples. At the end, what I'll show is how you can find some more in-depth information. So we have lesson plans, we have the standards listed, we have more pictures, we have more videos, we have step-by-step instructions, we have resource materials, and I'll share with you at the end of this presentation how to find those. And so we'll start off with examples. I'll show you some pictures and videos and kind of describe what's going on. And then at the end, I'll circle back and I'll show you where you can find the actual lesson plans and materials for all of these. All right, so without further ado, I'm going to pause here. I've got my camera on for this, but I'm going to turn it off for the next section because, like I said, I do have some videos I wanted to play, and when I tested it, it kind of got a little bit choppy whenever I had both cameras running. So I'm going to turn my camera off and go ahead and screencast the rest for the examples. So I'll see you in a minute. All right, so the first example I'm going to share with you comes from kindergarten. This is one of our very first lessons that we rolled out when we did the engineering design process. And it's called Huff and Puff Engineering. So it's all about the three little pigs. And we essentially give kindergartners a chance in pairs to build a better house for the three little pigs, to protect their three little pigs. And so we supply some materials, we walk them through the process, obviously. They have to draw out a plan of how they want to use the materials. And then they build a house. And then we put our little pig inside. And we get out a very, sometimes strong, sometimes not so strong hair dryer to test out their structures to see if they will survive. Before I go on, I did want to share this picture because I think it was cute. This is a picture of our some kindergarten students, and they've all got pencils behind their ears because they feel like engineers wear pencils behind their ears. So, all right, so let me show you a little bit about this. So essentially, here is the planning process, and so they are given some, like I say, materials, toothpicks, marshmallows. We have them draw out their plans, and then if you can see from that plan, not only the initial plan, but also how they improved it as they go. So there's that rapid prototyping, test, and rebuild. One thing I did want to note about this is you'll see the materials change. So on some of these pictures, you'll see gumdrops being used. And what we found out as we started rolling this process out was that gumdrops were too sturdy. And so the houses that the students built with the gumdrops were very strong and secure. The blow dryer could not knock them over. And so we decided to switch out the gumballs and not use that anymore, and instead use marshmallows, which again produced more failure. And so again, when you bring that failure into the classroom and you start these projects, please make sure that you're building that failure right in. Now, I'll just show you a quick little video. Once you do have success with these projects, this is what it looks like whenever you start testing these out and they work. So this is one of our kindergarten teachers doing a real test of one of the structures. All right, so a lot of excitement there, obviously, and you'll find that whenever you start testing these things out, um, a lot of excitement whenever they finally achieve success. So again, that's Huff and Puff Engineering, tied to Three Little Pigs. It's a literature-based engineering project. All right, another one of our original K-5 engineering projects that you may have tried with students before is called Egbert. And so this one is all about angles and friction. And basically, essentially, students need to design a structure that will allow their egg not to splat whenever it goes down a ramp. And so what we've done here is we've got these cars. You can see this young lady is holding up one of the cars we're using for this lesson, and she's got their structure built behind it. So essentially they need to plan out, using a scarce amount of materials. A lot of times we build a budget into this. So for example, you might have a $25 budget and each cotton ball is $3. Each roll of tape is another $5. And so they need to not only plan out how they're going to build it, but how they're going to spend their money wisely to get the best bang for the buck. Now, once they build their contraption and they put it into a Ziploc bag so the egg doesn't splat everywhere, they put it in the back of the car and they run it down a ramp. And the ramp can have varying levels of friction as well. So there may be carpet, there may be felt, there may be just straight wood to do the different tests on. The other thing that's great about this is it starts talking about angles and how the slope matters in addition to the friction. So these students have their contraptions that they've built along their ramps. And so one thing I did want to share is this short little video, again, of success of this particular group of students. They're checking their bag to see if the contraption they made actually protected their egg.
Go ahead, pull it out of the bag. You can open it. All right, pull it out. Do we have any yolk? Any cracks? Egbert lives!
So there, obviously, you see the excitement of Egbert surviving to live another day. And one thing I love about this one is a highly high amounts of failure within this lesson. A lot of eggs cracking. But one thing you'll never see is these students give up. They persist, they problem solve, and they make it better and better each time.
Go ahead, pull it out of the bag.
So the next example here is a middle grades example. So this is a, like I say, middle school example. This is regarding density, and it's called Whatever Floats Your Boat. And so this process is a little bit different, of course, a little bit more involved now that we're here in the middle grades. A lot more math, a lot more charting, a lot more figuring out what is the ratios and budgeting. And so in this particular case, what this lesson is all about is weight distribution as well as the density of the liquid that they're floating in. And so right now you're seeing the planning phase. And so these ladies are adjusting the materials. I believe that's a piece of foam that they're trying to cut to size their boat. You see they've got their styrofoam, they've got their plans out here. And what they're doing is they're building a boat and they'll be testing it. They test it into two different types of water. You've got just regular tap water, and then the other boat that they have is tested in a large vat of salt water. So a ton of salt placed into that container to test their boat out. And so essentially when they build these, they have to make two identical boats. One that goes in the regular water and one that goes into the salt water. And then they test to see how much weight each of them can support. And so here you're starting to see some of the weight being added. And so each one of these are measured out. So each one, I believe, well, I'm not sure exactly how many grams is each one. You can see the salt next to there. So you've got the two bins and this is the saltwater bin. And so essentially what you're showing students is you're showing them not only the process of how to build a better boat and get the most weight, which is part of the prospect and the task, but also they're recording how much weight is supported by each of these so they can track the density and see how that has an impact. Our middle school teachers, the reason that they came up and they decided to do this project is because density is a very tricky concept for middle schoolers. It's hard to teach density. And so like I said before, we look for our concepts that are the most difficult to start planning these lessons around, to really give them a more in-depth, hands-on view of what density means. So here, of course, you see the testing, and I just threw this other picture in here just because it shows, even in middle school, just like the elementary school, when you start testing, it brings a crowd. And that's one of the wonderful things about these projects is these students that are leading the way and showing that they've got the best structure. Then you start seeing all these other kids come around and start pulling their ideas and start asking them how they did it. And it's just really great to have that sharing of ideas openly within a classroom. So that is whatever floats your boat. That's a middle grades example. Now we're heading into high school a little bit. So this is a high school example. This is a high school civics class. And this is a class that was studying the Constitution and the Bill of Rights. And so essentially what this project was all about is building out 3D symbols to represent one of the Bill of Rights, the constitutional amendments. And so again, what you're seeing here is the actual 3D building in Tinkercad, which is the program that they use for this, which is a free program that works on Chromebooks, PCs, MacBooks. Excellent program for 3D modeling and very intuitive as well. And so essentially what these students are doing is they are building their own creative representation of that amendment. And so they're building out a symbol that shows their understanding of what that amendment is all about. This is one of our facilitators, Mr. Will Allred, walking them through the process of how to use Tinkercad and build these out. We are lucky in Moore County that we do have 3D printers available, and so we were able to take these designs that students made and 3D print them and actually have them in their hands. And the teacher here, Mr. Morris, utilized these to, again, get a deeper knowledge of those amendments. And again, that was a topic that was kind of one of the trickier ones to teach. And so here they have a hands-on 3D design built. And one thing I will also mention, if you've ever worked with 3D design and 3D printing, you know there's a lot of failure baked into that. And so we give students guides, but we don't show them everything so that when they do get to their print, they see that, oh, there's something that was too thin or there was something that wasn't connected, and that's a way for them to kind of rebuild and recreate and improve on their designs. Heading back to middle school, this is a grade 6 through 8 example that we developed in the last few years. And this one is all about light and diffusion and clarity and how to bring students more understanding of how light works in different mediums and also get them engaged with the building process of how to create a filter. So what you're seeing here is we've got Sphero robots that our students are programming and using, and that's essentially what they're using as their flashlights. And so the engineering and design part of this is they have a budget, they have a set amount of materials to create a filter for the Sphero in order to get the most amount of light through the sensor and to the sensor. And so what you're seeing here is obviously students building out of styrofoam. They get to talk about the reflection of the light within that styrofoam. They get to talk about the diffusion between the barriers. And as they figure that out and they start testing, they test it with an app, the Google Science Journal app, which automatically records different intensity of light. And so that's how they record their numbers, that's how they test them out. They check different ideas and they change the ratios to see how it works and how the light is transmitted through those flashlights. And here you see them being a little bit spooky after they're done. So again, the design here is building out the filter so that you can have as much of an intensity light and a directed light towards that sensor to get that as high as you possibly can. And that is built again through the spheros. I'll just go back here real quick. You can see he's got it in his hand. This is using his phone. That's a phone app. This guy Google Science Journal. And then the actual Sphero you can program with the Chromebook. All right, some more Sphero, and now we're back into high school. This is an advanced math lesson that works extremely well with the Spheros, and it's curling. And so if you're not sure what that is like in the Winter Olympics when they take these stones and they slide them across the ice and they try to get them as close to the center as possible and as many as they can. And so essentially what you're seeing here is in advanced math, they are working through speed, direction, rate of motion. They're working on the timing and the ratios and how to get it exactly correct so that it is as close to the middle of the circle as possible. And this is a awesome task for students to do, very hands-on, brings it really to life, allows them to apply those math skills and see it in real time. And the other thing that's great about this is it builds a lot of failure into it. So what students learn about this as they start to do their curling, and I'll show you here in a video in just a second, is that there is human error built into this. There is real life error built into these lessons. And so the spheros don't move perfectly. You know, in a textbook, you'll have a certain formula, you'll plug it in, and it'll say it'll go exactly 18.34 feet. Well, whenever you test it out and you actually program the Sphero, the same inputs that you're using in that textbook formula, when you get the output, you might be at 19.3 feet. You might be at 17.87 feet. When they do the measurements and how far they are off from the center of the circle, that is a real conversation about the difference between theory and practice. And so one of the great aspects of these lessons, especially when you get into high school, is having them do the traditional mode and then getting out into the real world and actually producing the outcomes and seeing how closely they match. And then talking about that. Why does that difference happen and why is that important? So here's just a quick video of Sphero curling with advanced math. All right, so moving on. This is a math-directed lesson. We have some drones in Moore County that we love to utilize, and this is a math lesson where students build an obstacle course given materials that their drones can fly through using freewheeling driving, manual driving, and not necessarily program driving. So the way that it works, you see this group of girls has their planning sheet in front of them. They are replanning, if I remember right from this picture. We've got pool noodles, we've got lengths of PVC pipe and connectors, and what they are trying to do is they're trying to figure out how to get this back in their budget. And so they've went over budget. You can see their PVC pipes there on the ground, their connectors, and they're trying to reconfigure to see how can they build the obstacle course that they want out of their budget. So each group builds a different section of the course. And so this group is building their own piece that the drone will try to fly through as they go. And again, this is a math-centric lesson. And so essentially they're working on those budgets. They're working on trying to figure out how they keep it within budget. They're working on structures, and they're working on shapes and best width for a drone to get through whenever it's flying through the course. Advancing here, you can see there's a student working to put together their obstacle course. This is PVC pipe, very cheap. You can get PVC pipe and cutters and make this out, and then these pieces are forever. You can use them a lot of different ways in a lot of different projects. And this is just a quick view of what it looks like. So now they're testing out. They're going through two of the pieces of the obstacle course, and the pair in the back, these students are driving manually with these drones.
Okay, go forward, forward, forward. Forward. Down, forward. Keep going forward. And
All right, so a bit of a failure there. They didn't quite make it through, but again, retry and try again and improve, improve, improve. And you can also, one other thing I want to mention is the creativity within these projects. Every group, whenever you do these projects, you're doing it, you know you're doing it correctly when each group has their own unique take on it. They can show their creativity, they can still do the task, but also make it very much their own. So you can see that in this video. You've got lots of different structures here. So here we are back in middle school, learning about simple machines. And this is the way that we do our Rube Goldberg machines, which you can Google that. That's basically just building a complex machine to do a simple task. And so we use pegboard and we use metal pegs. We reuse those over and over again. And again, students are given a set amount of materials, set amount of budget. And in this one, they are to create their Rube Goldberg machine using as many simple machines as they can and also labeling them as they go. And so here you see the PVC pipe that we're reusing from before. We've got cardboard, we've got tape, we've got the metal hooks, we've got pulleys, we've got levers, we've got wedges. And this is how these middle school students have been using these machines. And I just want to show a quick example. So here, first one is a failure of a Rube Goldberg machine failure. And so this is a group that had to redesign and redesign and redesign. And then finally, this wasn't completely a success, but it was a lot closer than the first one. All right, so that got close. And again, in this particular instance, a lot of times these students never succeeded. And so even though they never succeeded in doing the task exactly as they wanted to do, they learned a lot about simple machines and they never gave up on the process. Back to high school here. This is just a quick example of slope and rate of motion and rate of speed and speed change. And so students were building ramps at different angles, and they were programming the spheros, which can go a certain ratio of speed, to go over the ramp and to land in that pillow there that you can see. And so the design part of this is building the ramp at which height, which angle, to make sure that you're getting your slope correct as you fly your sphero over the ramp. So again, this students worked hard, redesigned, and here is an example of a final success from these high school students.
Oh yeah. Oh yeah. See what I'm saying?
So you'll notice that pillow there. So if you're using spheros to do this, make sure you have a soft landing. That's one thing that we learned. So again, ramps, high school, great examples. Back to K5. This is a classic one that we've used for a couple years. Solar ovens to build s'mores, or I'm sorry, to cook s'mores, built out of old pizza boxes that we get donated, aluminum foil, and this is all about convection. How can you build an oven that will melt your s'more the most successfully? And so you can see the different materials, again, budgets, plans, making sure that you've got the right amount of materials, a finite amount of resources. That is another big point in these projects, is when students are working through these, when the materials run out, they run out. We put a cap on that. We kind of try to make it as real world as possible. Here's the s'more in the bag waiting to be cooked, and at the outcome here, you can see once these get put into the sun, the convection does work and they do melt, and they're able to enjoy their s'mores on a nice sunny day. This is another one that we use Lego WeDo Robotics for. So WeDo Robotics are great tools. You can build lots of different simple machines. And this one are some marshmallow catapults. And so using Lego WeDo to not only build out the catapult, but also the different levers and the power and the speed and getting that just right, and also the programming abilities to be able to program these robots to work their catapult as well as they can. A lot of failures in this one. So here's one. They just didn't have it right. They didn't build their contraption correct, didn't throw it nearly as well as they could. They had to go back and redesign. Here are another couple videos. I believe this is another failure here.
Ready?
Yep.
Wait, turn it off.
Not quite.
Did you see?
So now we've got some success. So again, retool, retool until you find success. Now it's a very strong catapult. Good job. All right. So I want to finish up here just because I thought this was a really cute clip. When you start doing engineering, it's always very important to talk about what do engineers do? What are they? How are they? To make it an accessible career for students. You know, a lot of times students K-12, they hear the word engineer and they think it's unattainable. And so we really try to talk to students all the way down to kindergarten about engineers, what it is, problem solving, and why it's important for the world. So I thought I'd just end up the examples here. This is just a cute example of a kindergarten class speaking about what do engineers do.
Talk about engineers. What is an engineer and what do they do?
They build.
Tell your partner beside of you.
They build.
Maybe.
Engineers build something for like
They
real
build.
robots, but some engineers can't control that. They can make some paper. They can and they can make this robot. Guess what? They can make a house.
So let's.
So I love that because they're talking about what it is, they're envisioning themselves as engineers, and you can see she took control of the conversation, and that's another great piece to see. All right, so those are our examples. Like I said, these are just a few examples, and in my next set of slides here, I'm going to talk through how you can find the resource and materials behind these examples, and also a lot more that you can pull from in your day-to-day work. So last but not least, I want to direct you to where to find these lessons that I've shown you, and also how to find more that we've got distributed through North Carolina. We put all of our things up in our hub in the Go Open NC environment. And so if you go to Go Open NC and you click on hubs, you will see Moore County Schools as a featured hub. Just want to walk you through that real quick. So here's the link, goopennc.oercommons.org. You can also just Google Go Open NC, it'll take you right here. Once you are here, you're going to come up to Hubs, click on it, and you'll see Moore County Schools logo right here. Now, what are you going to find in this hub? You're going to find a lot of resources, a lot of lessons, and a lot of projects. And so if you scroll down, you'll see there's a K-5 and a 6-12 section. Those two sections have resources. And really the largest source of resources here is the K-12 Design Thinking group down here. You can join this group, and I encourage you to do that. It runs it through your NC EdCloud login. And here in the group, just to show you how it's structured, is you've got K-5 lessons, you've got 6-12 lessons, and when you click on those lessons, I'm just going to go to K-5 real quick. Here's a solar oven engineering, which we talked about a little bit. When you click on this resource, it's going to bring up the full resource here, and it'll give you the link here to view the entire thing. So here you've got the instructor directions, you've got the driving question, estimated time, materials, standards. All of that is laid out right here within each of these lessons. We are also going to be adding more to these lessons, and so we're going to open up an opportunity for educators across North Carolina to contribute more to this hub, so stay tuned for that. Another place to go for some ideas are Twitter. We post a lot to Twitter, And so our Twitter tag is MCS Digital. If you go to that Twitter handle, you'll see lots of more different pictures and videos of projects as we go. We've also got a couple hashtags that we've organized this around. K5 engineers. We've now transitioned to K12 engineers as we add to 612. MCS ACE is focused on projects or a digital teaching and learning grant for 612 classrooms that use design and engineering within them. So I've got those linked up here in case you want to follow those resources, and like I say, those stay constant. And so as we do more, we'll post them to those hashtags into that Twitter account. So here we are at the end of the session. Thank you so much. I really appreciate you attending and taking a look. I hope you got to see some examples and start thinking of your own classrooms and what are the difficult things that your students are having trouble with and how you can reinvigorate that with engineering and design in your classroom. If you've got any questions, you can find me on Twitter. I'm EdTechSteve. There's my email address. And the last thing is, please make sure to fill out an evaluation. The link is bit.ly/K12ENG-S1, that is case sensitive. And so when you go to that eval link, please give me your honest thoughts. And once those evaluations are filled out, you'll be sent your CEU certificates from there. So thanks again. I hope you enjoyed it, and I hope you enjoy the rest of the conference.